Welcome back. Let's do some more rotations. So I've got a little exercise here where we're taking this little pyramid shaped thingy and we're doing a series of rotations. This is just for practice to build skills in AutoCAD and to help you improve your visualization skills. So the first thing we're going to do is we're going to take this front view and rotate it over really an arbitrary angle. And then we'll reconstruct the top view and the end view as appropriate. So remember, as you turn this view, the height of the top view stays the same and the width of the side view stays the same. So we can build projection lines in this view, and then we can move those or copy them over to here and use the rotated front view to project up into the new top view and over into the side view. So we're going to do that, and I'll do it for you in a minute. And then once that's done, let's see, step 3, what I'd like you to do is just another arbitrary rotation. You're basically starting over with this stuff, and you're going to take this thing and rotate it an arbitrary angle. It doesn't even matter, it's arbitrary. Now once again, the theory here is that as you rotate this top view, the height of both of these views stays the same, but the width of this view is going to change, and the width of this view is going to change. So we'll do that, but we can so we can take these horizontal lines and bring them down here, and then we have to construct a brand new set of projection lines for the other two views. So we'll do that. Then the third or the fourth thing I want you to do is start with this view and take this end view and turn it once again some arbitrary angle. Turn this guy, and when you do that, let's see what's going to happen. These two views, turns out these two views will stay the same width. That might be a little bit hard to visualize, but that's what's going to happen. So because of that, you can just bring these projection lines straight down. Okay, and then to get the other dimensions, you got to project through a 45 like that, and then straight over like that. Okay, that's the theory and kind of the steps that you need to take. And it's, once again, it's just to help you with your visualization skills and to help you improve AutoCAD speed and skill. All right, so I'm going to do this for you. I'll pull this guy off to my secret hidden monitor, and I got AutoCAD up, and I drew this thing already for us. Okay, first thing we're going to do, we're going to take this view and turn it some arbitrary amount. Actually, before I want to do that, I want to build some projection lines. So I'm going to build a 45-degree line, or draw a 45-degree line right here. Make sure this guy's 45. You want to double check that in the properties window. Oh, the other thing is, these guys, it's a little different than the instructions that I just showed you, and that's fine as long as these three views agree with each other. That means if this is an inch, then this needs to be an inch, and if this is 3/4, then this needs to be 3/4, and if this is a half, then that needs to be half, and this is a 1/4, so that needs to be a 1/4. So you can vary the shape, dimensions a little bit as long as the three views agree with each other. All right, so I'm going to build some projection lines. I'm going to come off way over here, and the grid's going to help me here because this thing's all laid out on the grid. It's only a couple of lines to draw for this guy. I'm just using the grid. Could also use object snaps. Okay, I'll trim up, trim, cut that off and cut that off. Okay, let's take this stuff and this stuff and copy it over here with ortho on. Drop it here to do step 2. Okay, so this height in here is going to stay the same, and this width is going to stay the same as we rotate this. So I'll rotate this just right there. I'll rotate it, you know, it doesn't matter really. Just, I don't want things to be on top of each other, or I don't want the projection lines to be on top of each other, so I'm just going to put it right there. Let me move this up a little bit into the projection lines, or so that they, you know, so that when I project it, they will intersect. Okay, now I'm gonna with ortho, or rather with object snap, endpoint snap, and ortho on, I'm just gonna draw a bunch of lines way out here. Okay, draw those, and then those same 4 points come up. So I just have endpoint snap and then ortho on. Then I'll trim this just to make it look pretty. I'll trim these. So let me start over here with the trim. TR trim, enter. Yeah, if you do this right, you can. It's kind of slick. I'm kind of digging this whole trim. Yeah, that's neat. All right, let's, where's the thing? Where is he? Well, the thing to realize is that these two short little lines, as this guy rotates, they're gonna move to the right, right? This little line and this little line are gonna move to the right, and they're gonna be lined up with this thing and this thing. Yes? Yes, so, basically right here and right here are those two lines, and then that means the box on the top is going to be look like this. Yes. Likewise, this line's going to move to the right, and this one's going to move, well, not so much move, but be lined up with this and lined up with this. So in other words, there's a line here lined up with this corner, and then there's a line here lined up with this corner down there, and this guy here is hidden. He's on the bottom, so we'll make him hidden, and that right there, and then the remaining lines are from the corners, right? F8 was fighting me for a minute. F8 will do that. Goes to the bottom corner and then up to there, right? Do you agree? Vote now. So that's what it looks like. That's what the top view looks like. Whoops, right in there. Okay. What about the end view? What should we do in here? Well, let's see. This line here, that's gonna kind of pretty much stay down in here, right? And then this corner right here is it's gonna go up to like in there, which means it's on this line. So, so that means there's a line right here. The same kind of thinking will help you determine that there's a line here and a line here. Same kind of thinking about it that way. And then we just got to connect the dots. We're going to have a rectangle up in here and a rectangle here for the base. And then we connect these corners. That's that thing. And this and that is hidden. Okay, that was exercise 2. Exercise 3 we're basically going to start over with this thing and turn the top view and see what happens. So the thing to remember here, like conceptually wise, is that as you turn the top view, the heights of these other two views stays the same. And try and imagine that happening. Like pick up a little block on your table, on your desk, if you have something that's kind of cubic or whatever, and turn it around, and then imagine looking down on the various views what's gonna happen, and you should be able to convince yourself that these guys stay the same height. So basically all I need is these two lines down here, and I'll just copy them down. Whoa, what happened there? This guy and this guy, do a copy and just drag him. You know, really, it's 3/4 inch tall. I'm just gonna draw two lines 3/4 of an inch apart. It'll be faster because the height stays the same, and the height is 3/4 of an inch for those guys. So I'll just draw two lines that are 3/4 of an inch apart. All right. And then now what happens? So now you take this guy and copy him down here, because we just want to turn it. It's really an arbitrary exercise in turning a view and seeing what the other two views do. So copy him down, then select him again and do a rotate. Just pick some point anywhere and turn it. Now you want to turn it such that you don't have anything vertical. Like that would be bad. Right there would be bad, because I got a couple of vertical and horizontal lines are just going to make me think too much. So about there looks pretty good. Okay, now we'll project down endpoint with ortho on. Should have 8 points, right? So it should have 8 lines. 1, 2, 3, 4, 5, 6, 7, 8. That's 8 lines. And I'll trim them up with my super magical trim command, which I'm really digging. Then we want a line that we can project through. So we just want to make sure that it's going to intersect our projection lines. So that's about long enough, and then make sure that it's 45 degrees. Okay, now same thing, but we'll go from here with ortho. So you have missed. Here, I gotta make that guy a little bit longer. There, all right. Then these endpoints with ortho just go through the 45. Whoops. My endpoint snap grabbed my line, stole it. Okay, got to get in here and get the right stuff. So grid snap is not helping. I'll turn that off. I want that out to there. Then that thing, then there's one there, there's one there. It should be 8 lines, right? 1, 2, 3, 4, 5, 6, 7, 8. Then come down with them. Oh, this is going to be fun. Okay, I got 8. 1, 2, 3, 4, 5, 6, 7, 8. Trim them up so that it looks pretty. Or neat, I suppose, might be a better term. Strictly speaking, I don't need these. I just like this version 12, version 2002 trim. It's kind of cool. You know, I can get these. Okay, just to be clean and neat and handy. All right. What now? Well, the height stays the same on these two views we were saying before. That means the top and the bottom just stretch out, but they stay on these two lines. So all we got to do is find the top where it is and the bottom where it is. It shouldn't be too hard because it's between here and here is the bottom, right? So there's a line. There, go to heavy. Red. Once again, this line and this line here bound the bottom. So there's a line from here to here, that's the bottom. And this line and this line are the outer bounds of the top. So there's a line here, here. Just strictly speaking, that's two lines. I mean, I could draw it. It'd be more accurate to draw it from here to here and then another line to there. In other words, there's a little line there which represents this line, and then there's another line here which represents that line, and that's helpful for connecting the dots. So yeah, let me go ahead and you know what, I mean, you know, if it's confusing, you could actually color code this a little bit better. Like you could make that green and make this green, something like that, if that's helpful. And we could do the same with the base, because there's a line between here and here. That's the, so let me draw that. And then there's another line. Here, I'll delete the one that was underneath that. There's another line from here to here, which I could make. You know, you could make another color. I don't know if that's better, but the we just got to connect the dots. I'll go ahead and make that green. Which this, so this green line here corresponds to this green line right here. Okay, does that, maybe that helps. So I'll connect these there, right there, and there, and then just following the projection line that goes to the back corner here on that guy. That's it. And I guess just to be more consistent, I'm going to go ahead and make these guys green as well, so that the whole surface, that whole surface is green, just to make it stand out a little bit better. This is hidden. So I don't know if the green's helping, but anyway, there it is. Okay, what about what's in here? We can do the same thing. This line is in the foreground in the end view, and it's bounded by this and this. Let me, that could be trimmed off, right? Yeah. This line is in the foreground in the end view, and it's bounded by this and this. So there's a line here. Sticking with the green motif. There he is, and this line is bounded by that and that, or rather that and that. So there's a line in here, and then there's a line here, and there's a line here, and that's our greenness. It's the greenosity right there. And I'm just staring at it to... There's a mistake here, right? I went to the wrong... It's this bottom line. I went to the wrong line right here. Right there. Okay. There's a similar triangle around back. I could even copy it. Nope. Yep. Right? Yep. That's it. Looks kind of odd, but I think that's correct. So let me make these red, and then we can kind of double check it. Is it right? It's not right, is it? It's so this one here. Yeah, I think this thing should be mirrored, actually. Let me mirror it about, see if I can grab, I can shift, right click, midpoint, override, and see if I can grab the midpoint of this guy, and then ortho straight up, and delete the original. And yeah, that looks better. Now this guy's bounded by that and that, which travel over to this and this. And there's supposed to be a line in here. Where'd he go? I don't know what happened to that guy, but anyway. Did I mix up the green with the... Is this green the same as this green? Yeah, it is, right? There should be a line up in here somewhere. I guess it's red. I guess to here, maybe. Yeah. And one of these is hidden. Maybe this one, right? You think? Because it goes to the... It lines up with this over here. Just on the back side, so it's green. It's hidden. You know, that kind of thing. It's a little bit of thinking. It's a little bit of guessing, and it's a lot of checking. Hey, there's that line that got away, I think. Anyway, okay, that was step 3 in this process. All right, step 4, what I want you to do is do another rotation on this thing. Okay, so that's what we're gonna do. Let me pull the instructions up for a second here. So we did this. Now we want to take this guy and rotate it at an arbitrary angle that much. The theory being that as you turn this guy, the height of this view stays the same. No, sorry about that. Misspoke. As you turn this guy, the widths of these two views here stay the same. That's the theory that the concept that you'd have to kind of prove by actually turning something in real life and kind of like imagining what the orthos would do. It's tricky, but I'm not sure how else to what else to suggest that would to help you. That's the only thing there is to do, really. Okay, so yeah. So let's do that. So I'm gonna take so the width here stays the same, and Ah. That stuff. And those two lines I need. I'm going to copy them down here. Then just to be a little, to have some more to work with, I'm going to lengthen these up a little bit. I could also stretch. Just lengthen them. Okay, I need a 45 to project 2. So I'll put him, can I squeeze him in here, you think? I gotta go back to my skinny lines. I want him, you know, I want to be able to project up into him, so I need him to be to the left of this thing, and then has to pass all the way to the right and still be 45 degrees. So it looks to me like something like that would do it, and then 45. Okay, then we'll start projecting up from endpoints, and then with ortho 1, just go all the way through these guys. Oh, I forgot to rotate him. Yeah, the whole point of this was to rotate this guy, which I totally forgot to do, so we'll do him now. What happened? One more time on the rotate. So select all this stuff, RO for rotate, pick a rotation point, and then turn off ortho so that you can do this kind of thing. So once again, you don't want anything vertical or horizontal because it'll just lose information, right? If I had a vertical line and I project it up, I mean, I only have one line instead of two when I project, so I'm going to lose information, so I don't want that. It's kind of hard to get this guy so that nothing is vertical. That's about right. Let's scoot him over a little. Just move him over, just, you know, move him over like, actually kind of right there would be good. Okay, now let's do the projections. So we want to grab every line, and with ortho on, just do this. Is that 8? 1, 2, 3, 4, 5, 6, 7. Yeah, it's 8. Then from the intersections this way. Yeah. Okay, and then trim it up. And, you know, once again, we could cut off these guys that poke up like that because we don't really need those guys anymore. Okay. And some more projection because it's so fun. Go this way. I'm going to go perp so I don't have to trim anything. Just going to use the perp snap. Yeah. This will get you faster at AutoCAD, that's for sure. Those are close. Is that 8? 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. Yep, that's 8. Trim off this extra stuff poking out. Oh, you know what? I missed a line. Remember, these 3 lines stay the same width when you do this, when you rotate this end view. Okay. We just got to find the shapes. Let me just stare at this. That's what you have to do, really. So I'm going to pause it, and maybe you should do that too, and just stare at it. Okay, I stared at it for a good like minute or two, and the thing to realize for this is that, well, you know, the width is staying the same here on these 3 lines is staying the same. What does that mean? It means that this line, and this line, they just move up and down because, you know, the points on them are not moving side to side. There's no points moving side to side. So those, and this one too, those guys just move up and down. So all we need to do is locate them vertically. And that's the case for both of these views. Both of these views down in here. So let's do that. So this line, which one is that in this view? Is it that one? No, it's this one, right? Because let's see, this line becomes this point, which becomes this line, which gets turned down to this line. So basically this line there is lined up with that line. So this line here is bounded by the 2 lines coming off of this guy, which is like this one and this one. So in here, right in here, there's a line, right in here. Which I forgot to do red. I'm going to draw it before I lose it. There it is. Then click it and make it red. That's that guy. Then likewise, well, this one here must be this one, which is bounded by these 2. So that means there's a line. I forgot to bring down another line, didn't I? Shoot. So there's a line right here that I forgot to bring down. Let's bring him down right there. And really, there's another. So anyway, that there's a line. So let me go to red and I can finish this up. Okay, so this hidden line corresponds to this line because they intersect on there, and that's one way to think about it. And this line corresponds to this line, which is bounded by these 2 lines. And then it's in here. It's right here. That's that. Okay, we can do that the same thing with these 2 little short lines, that one and that one. So this one matches this one, which is bounded by these 2, which corresponds to these 2. So there's a line, let's see what happens. This is this line, that line, it's in here, right? It's right here. Then this line corresponds to this line, which corresponds to this line, which is bounded by this one and this one. So coming down from this guy, it's right here. So there's a line right here. Now all we have to do is connect the dots. And you may have noticed that I mixed those up. See, this guy and this guy are together, which corresponds to this guy, this guy, this guy. Yeah, I mixed it up, right? So really I reversed those. So let's flip that around. So there's really should be there. And that means get rid of this guy. And then it should be here. I mean, it's a double check. I mean, we want parallelograms. So those two have this arrangement, and these two have to have a similar arrangement. All we need to do is connect the dots now. There it is. And something in there is hidden. Oh, I missed a line as well. There's a line here, right? This is one of those optical illusion things, finding out trying to see who's hidden. You think it's that? Let's see, this one here, and this guy here rotates around to that. And, you know, that means this one would be hidden. I'm going to go for that one. I'm going to bet on these three, actually these three. That's my bet. And I could have this backwards, but that's what I'm betting right now. You think? What do you think? I'm going to stick with that. Okay, we just have to do that again. So, once again, this guy and this guy come down. They're going to be somewhere on these two lines. And we just have to match them up with the appropriate. So let's see. This guy is this guy, which is between these two guys, which is this guy. Then we come up through these two guys over. Oh, I missed a line. Over there. That was one of them, and the other one was this one. So it's that one and that one, and was it this one? Right here? Yes? No? Then let's see, if that's true, then there must be another one between this one and this one, which would be those two, this one and this one, on that one. So that means in here. Okay, if it's not those two, it's reversed from that. And I think it's reversed from that because yeah, you know what? I think I might have this wrong down in here, because as you tilt this view, as you rotate this guy clockwise, what you're doing is you're exposing the bottom of this thing. So that means these are all going to be solid. And it's kind of an optical illusion thing going on here. And if the bottom, if you're seeing the bottom, then this must be hidden, and this must be hidden. And this must be hidden. Let's try that and see if that looks any better. Well, it doesn't look worse. I'm going to go with that. Let me see if I can get these other two lines drawn. So this one here and this one here I need to draw. So this guy here is it's this one, right? Yeah, because they line up together on this. So if it's this hidden one, that gets rotated to this position, which is bounded by this one and this one. So actually vertical, we're going vertical. So it's this one and this one, which are this one and this one, which means there's a line right here. Yeah. Then the last one, this hidden line, which corresponds to this solid line because they intersect on these two. And this solid line here gets rotated to this position, which is bounded by these two. Ooh, once again, I went the wrong way. It's these two. No, those two. So that's these two. So there's a line. There's a line right in here from this point to this point. All right. I can see some parallelogram action happening in there. Let me get that drawn. We got our parallelograms. We'll connect the corners. And then we'll do the little what's going on with the hidden lines fun. I think the bottom is still hidden on this. It doesn't turn so much that it's exposing the bottom on this. I don't think. So let me make those hidden and just look at it and see if that looks. So you know what? I'm going to go with that. I think I could spend some more time and study these lines to see if it's correct. It's different than what I've given you in the handout because I chose some different dimensions and some different rotations. But anyway, just draw something like that and do the rotation and the projections and do it again and follow the lines. It's a really good mental workout. It's a really good technique for problem solving in general, and it shows up not just in design of parts but in analysis. Like if you take a statics or mechanics, stress of mechanics or things like that, you're going to be doing, you're going to be figuring out stresses and vectors and forces, and just being able to visualize this kind of stuff and draw it out a little bit better is a useful skill. Okay, have fun with that. Hope this was useful to you. And see you next time. Bye.